Ah, the summer solstice. The beginning of summer. Or is that the equinox? Wait, is there even a difference? As it turns out, solstices and equinoxes are sort of opposites. We know that seasons are caused by Earth having a slight tilt on its axis. As Earth wobbles around the sun, different points of the Earth receive more or less sunlight throughout the year. If Earth wasn't tilted, the sun would just shine directly on the equator all year long, leaving us without seasons and wrecking everyone's summer plans. But we also wouldn't have solstices or equinoxes. Solstices designate the point where the sun's path in the sky is the farthest north or south from the equator, which occurs around the 20th and 21st of June and the 21st and 22nd of December. The summer solstice marks the beginning of summer and is the longest day of the year, just as the winter solstice marks the beginning of winter and is the shortest day of the year. But which solstice happens on which day depends on the hemisphere you live in. In the northern hemisphere, summer starts in June when the sun is beaming directly over the Tropic of Cancer, while winter starts in December when the sun shines down on the Tropic of Capricorn. This is flipped for the southern hemisphere, which is why Australians associate the new year with summer fun. Alright, so what about equinoxes? Well, that's simple. The equinoxes are when the sun is right over the equator, in between the two tropics. They occur around March 21st and September 23rd, and mark the beginning of spring or autumn. We call the beginning of spring the vernal equinox, while the beginning of autumn is, conveniently, the autumnal equinox. Again, which is which depends on the hemisphere, but during both equinoxes, day and night last the same amount of time. Here's a handy mnemonic device. Equi means equal, and nox means night, which tells you that the day and the night are of equal length. So at the end of the day, while solstices and equinoxes are related, they happen at different times of the year. Just remember that solstices are the longest and shortest days of the year, while equinoxes occur when the day and night are equally as long. Regardless of whether it's a solstice or an equinox, there's bound to be a celebration happening somewhere.
Pluto was first found nearly a century ago, in 1930, and the uproar at the discovery of a new planet was tremendous. In 2006, there was another uproar, as the beloved ninth planet in our solar system was given a highly publicized downgrade. Pluto, scientists told us, should no longer be called a planet, but instead a dwarf planet. Well, what does that mean? Why should we change our minds? Is Pluto a planet or not? In 2006, the International Astronomical Union considered a controversial question. What is a planet? Up until then, planet was defined pretty loosely. It just referred to big objects in the solar system. But which objects exactly? Some moons, like Jupiter's moon Ganymede, are larger than the planet Mercury. And some objects, like Eris, have never been known as planets, despite being very nearly as large as Pluto. So, what makes a planet a planet? The IAU came to a decision that would annoy Pluto's fans even a decade later. They agreed on updated criteria for planethood. To classify as a planet, an object must orbit the sun, and not another planet, and it must be massive enough for its gravity to have pulled it into a roughly spherical shape. No problem for Pluto there. Unfortunately, there's another qualification for planet status. To be a planet, an object must be large enough to have cleared the path of its orbit of other debris orbiting the sun. Unlike the 8 planets the IAU now recognizes, Pluto hasn't managed that. Checking every box except one means that Pluto can't be considered a true planet. Instead, it's classified as a dwarf planet, along with Eris and other large objects like Ceres, Haumea, and Makemake. The ranks of the dwarf planets may grow over time, too. Since they are relatively small and usually very distant, scientists believe we haven't found all of them yet. But don't feel too bad for Pluto. Being a dwarf planet isn't really a downgrade. It's just a change in how we talk about it. In 2015, the New Horizons spacecraft sent us the most detailed pictures and data about Pluto we've received yet. We found that the dwarf planet has geological features we hadn't imagined. Towering mountains, ice ridges, vast smooth areas of carbon monoxide ice. What we call Pluto can't change the spectacular reality of it. So maybe your very elegant mother has to serve you noodles instead of 9 pizzas. But sometimes change is good. Science can't advance without changes in how we understand the universe. Pluto's still out there, and as we learn more about it, we understand just how spectacular it really is.
In 1969, a celestial light show burst through the sky over Chihuahua, Mexico. These lights in the sky are called meteors. Or is it meteorites? Maybe meteoroids? Are those all different things? And if they are, what is the difference? Actually, they are all different, but they're pretty closely related. The streaks of light are in fact meteors. But the small rocky bodies that cause the lights, those are meteoroids. And when a piece of a meteoroid survives the trip and hits the ground, that object is called a meteorite. So let's talk about our Mexican light show. It actually started out as a single object about the size of a car flying through space. That object was a meteoroid, a body orbiting the sun that's smaller than an asteroid or comet. In February 1969, that meteoroid hit Earth's atmosphere and it hit it fast. Meteoroids fall at a minimum speed of 25,000 miles per hour. At that speed, the friction from the air began to heat up the object. In fact, it made it so hot that it began to burn brightly across the sky as a meteor. This particular meteoroid didn't just burn, it exploded into pieces. Now, most meteoroids burn up entirely as meteors, and some of these pieces did just that. But a few made their way through the atmosphere to hit the ground. Those remnants are known today as the Allende meteorite. Yeah, even though there are lots of stones, they're all considered part of the same meteorite. All in all, about 2 tons of this meteorite was recovered. Study of the Allende meteorite reveals that it is one of the oldest objects in the solar system, older than Earth itself. So where do meteoroids like this come from? Well, almost all of them are actually fragments of asteroids, the larger rocky bodies that orbit the Sun in a big belt between Mars and Jupiter. A few, though, are actually moon rocks, and some even come from Mars. So if you ever see one of these interplanetary travelers lighting up the night sky, now you'll know that you're seeing a meteor caused by a burning meteoroid. And if you're very lucky, you might even find a meteorite when it hits the ground.
Eclipses are spectacular astronomical events that have been gluing eyes to the skies for millennia. You might know that there are 2 major kinds, the solar eclipse and the lunar eclipse. A lunar eclipse is what happens when the Earth passes between the sun and the moon. And a solar eclipse is what happens when a celestial dragon devours the sun. Well, that's what people in ancient China claimed, anyway. Their tradition held that a dragon would attack and swallow the sun, but could be driven away by loud noises from the people on Earth. Many cultures believed some supernatural creature was attempting to eat the sun during an eclipse. Lucky for us, they never succeeded. Today we know that a solar eclipse is when the moon passes between the Earth and the sun. Not as interesting as a dragon, of course. The moon's shadow, or umbra, is cast on the Earth, and anyone in the area of the shadow sees an eclipse. And yes, a lunar eclipse is when the Earth passes between the sun and the moon. The Earth casts its shadow on the moon, which makes the moon appear dark from Earth. And you've probably heard of a total eclipse of the sun or the moon. But a total solar eclipse and a total lunar eclipse are actually pretty different. The Earth is a lot bigger than the moon. A lot. So when the moon casts its shadow on the Earth during a solar eclipse, its shadow doesn't fall on the entire planet. Instead, its umbra moves across the Earth. People in the path of the umbra may see a total solar eclipse. People along the edges, though, will only see a partial eclipse. The moon will obscure the sun, but not block it entirely. And in some places, people won't see an eclipse at all. On the other hand, when a total lunar eclipse occurs, where you are on Earth doesn't make much difference. The Earth is so much bigger than the moon that you'll be able to see a total lunar eclipse anywhere on the night side of the Earth while it's happening. But you can still get a partial lunar eclipse. Sometimes the moon passes along the edge of the Earth's shadow, a dim area called the penumbra. There's also a phenomenon known as an annular eclipse. People don't talk about annular eclipses too often, which is too bad because they're awesome. An annular eclipse is a solar eclipse that occurs when the Earth's orbit brings it relatively close to the sun at the same time that the moon's orbit takes it relatively far from the Earth. When that happens, the sun appears larger than the moon in the sky. And so a ring of sunlight is visible around the moon at the height of the eclipse. There are no annular lunar eclipses because the Earth is so big that its umbra always appears larger than the moon. The moon literally can't get out of the Earth's shadow. So next time you hear about an eclipse on the news, you'll know that in a solar eclipse, the moon passes in front of the sun and casts its shadow on the Earth. In a lunar eclipse, the Earth passes between the sun and the moon, casting its shadow on the moon. But if you want to pretend a celestial dragon is involved, we won't blame you.
The sun's magnetic fields are in constant flux, flowing in complicated ropes that can break through the sun's surface before dipping back down. Sometimes, those arcs of magnetic field can rapidly realign, creating enormous blasts of energy that move away from the sun. This can result in the sun emitting sudden flashes of light, called solar flares. Another such blast drives off solar material called plasma. These events are known as coronal mass ejections, or CMEs. Forming massive expanding bubbles of hot gas that escape the gravitational pull of the sun, CMEs can travel over 1 million miles per hour. Although this is slower than the speed of the light and materials emitted by solar flares, coronal mass ejections can have much more dramatic effects on Earth. They have the potential to overload power grids, disrupt communication channels, and interact with Earth's own magnetosphere. So astronomers pay close attention to the rare CME pointed toward Earth. Not all effects are unwelcome, however. When a balloon-shaped CME reaches Earth, our planet is enveloped in supercharged particles that interact with our own magnetic field. Certain magnetic patterns can force these particles down toward Earth's poles. The captivating light of the auroras is the result, sending colorful trails across the skies of the North and South Poles. One of the strongest recorded CMEs in 1859 caused auroral lights that were seen all the way to the tropics.
The largest garbage dump in the world is not the Apex Regional Landfill or the Great Pacific Garbage Patch. It's actually so high up in the sky that it's invisible to the human eye. 100 to 1,000 miles above Earth's surface is a region of space called the low Earth orbit. This area is the perfect destination for space stations, satellites, and telescopes, and unfortunately, for their trash. When spacecraft are retired, they are either programmed to fall back to Earth or turned off and left floating in orbit. The low Earth orbit has now become a junkyard where millions of pieces of space debris float around billions of dollars of active satellites. This debris can be as large as a discarded part of a rocket or as small as a chip of paint. Unlike your typical garbage dump, space junk isn't just sitting in a heap. It's moving very fast. Propelled by Earth's orbit, space debris can reach speeds of up to 18,000 miles per hour. Moving at such high speeds, space junk can be destructive. Even a piece of debris as small as a grain of sand can damage space shuttle windows and force astronauts to make risky replacements. Over the past 50 years, an average of 1 piece of space debris has fallen to Earth's surface every day. Most debris burns up as it falls back to Earth, which creates metallic ash that can disrupt the atmosphere. Many of the pieces that make it to the ground are large enough to do some serious damage. In 1978, NASA suggested that the buildup of space junk in our orbit would cause a chain reaction. The more debris there is floating around, the more likely collisions are to happen, which creates even more debris, which creates more collisions. You get the picture. This buildup of space junk could eventually make the low Earth orbit, home to satellites that power technology like GPS and the internet, unusable. There aren't any legal regulations on space trash, and scientists are unable to fully catalog our interstellar pollution. One estimate from NASA is that there's more than 9,000 tons of space debris in low Earth orbit. That's the weight of 60 blue whales. In 2010, only 1,000 satellites orbited our planet. 15 years later, the number is closer to 10,000. So keep an eye on the sky, be careful out there, and don't forget to recycle.
How beautiful it is, our cloud-wreathed spaceship, planet Earth. How beautiful and how small.
How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.